All right, guys, we're continuing on with our linear functions unit. We're going to compare our proportional versus non-proportional. All right, remember that when you're talking about proportional relationships, we also call them direct variations. All right, so let's take a look at this situation. Company A charges a rate of $40 per day. Company B charges $60 plus $40 per day. So Company A is going to charge you $40 per day. Company B is going to charge you a $60 fee plus the $40 per day. All right, so when we look at our two different situations, this one is in the format of y equals kx, where if you remember, k is our constant of variation. This one is in the format of y equals b plus mx, or the way we are used to seeing it, y equals mx plus b. Remember, they can be flipped. Okay, we called this a direct variation, which just means, in fancy words, that this should be a proportional relationship. All right? And this relationship should be non-proportional. So let's check to see if we are correct. All right, so filling in our data and doing our math, at 0 days, it should cost $0. 1 day is $40. 2 days is $80. 3 days is going to be $120. And 5 is going to be $200. All right, so if I want to look at this data and figure out if it is a direct variation, you set up your y over x column. Remember, y over x is not your delta y over delta x. Delta y over delta x is slope. This is our ratio column to verify if it's proportional or not. Because if it's proportional, by definition, our ratios should all equal. So we're going to set up our ratios: 0 over 0, 40 over 1, 80 over 2, 120 over 3, and 200 over 5. When we reduce our ratios, 40 over 1 is 40, 80 over 2 is 40, 120 over 3 is 40, and 200 over 5 is 40. So therefore, our ratios are equivalent. Therefore, this is a proportional relationship. We call it a direct variation, which means it should be in the format of y equals kx, where k is our constant of variation. And it does match. Y equals kx is y equals our 40 times d. All right, let's take a look at the second one. In 0 days, it's going to cost us $60. In 1 day, it's going to cost us $100. In 2 days, it's going to cost us $140. In 3 days, it's going to be $180. And in 5 days, it's going to cost us $260. So to figure out if it's proportional or not, we set up our y over x. So it's going to be 60 over 0, 100 over 1, 140 over 2, 180 over 3, and 260 over 5. When we reduce our ratios, and we're not going to do this one because remember, you cannot divide by 0. We're starting here. 100 over 1 is 100. 140 over 2 is 70. So immediately I see that these are not at a constant ratio. So therefore, that means that there is no constant of variation. Therefore, it is non-proportional. So it should fit the format of y equals mx plus b, and it does. All right, now let's take a look at it as a graph. When I graph Company A starts at 0, 0. At 1, it's $40. 2 is 80. 3 is 120. And 5 is at 200. All right, so this is company A. And when we look at company A, our graph goes through the origin, so therefore it is a proportional relationship. Remember, all proportional relationships cross through the origin. So it matches with everything else that we said. It has a constant of variation. It fits the format of y equals kx. All right, company B, when we graph it, it's at 0, 60. At 1, it's at 100. At 2, it's at 140. At 3, it's at 180. And at 5, it's at 260. So here's our data, and this is company B. And when we look at company B, it does not cross the origin. This is our y-intercept, which is our B value. And when we look at our graph, it matches the data. There was no constant variation, no constant ratios. It's in the format of y equals mx plus b, which we can flip and put as y equals b plus mx. All right, let's take a look at the next example. All right, remind yourself of what slope is. Slope can be called rise over run. It can be called our delta y over delta x. It can be called our change in y over change in x. It can be called our y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, so when we are looking at this, remember your format for a non-proportional relationship. M is your slope, and B is your y-intercept. Okay? In a direct variation, you are in the format of y equals kx, where k is your constant of variation. All right, so let's take a look at these two. We need to identify the slope, the y-intercept, and then write an equation. All right, so when I look at this, I automatically see that this is crossing through the origin. So right away, I know that I have a direct variation. All right, now if I have a direct variation, I know I'm going to be in the format of y equals kx. So we're looking for our constant of variation, which is going to be our slope, because constant of variation means that your ratios all come out the same. So we find two clean points, and when I look at my points, always pay attention to how they're counting. They're counting by ones on the independent variable. They are counting by fours on the dependent variable. So I'm rising up 8, and then I am running over 1. So my slope is 8. So my format is going to be y equals 8 times x. All right. Now our y-intercept is going to be at 0 because it is crossing at the origin, 0, 0. All right, looking at the next one, I automatically look at my graph and see that it is not crossing through the origin. Okay, so therefore this is a non-proportional relationship. So I know I have to be in the format of y equals mx plus b. All right, so when I look at this, the b is my y-intercept. The m is my slope. So we start filling in our data. The slope, I look at my data, I'm counting by ones on the independent variable, I'm counting by ones on my dependent variable. So now I pick 2 points, and I'm rising 1, and I am running over 1 also. So that means my slope is 1. So I have 1 times x. B is my y-intercept, where it crosses the y-axis, and it's crossing the y-axis right here at 6. So this right here is my y-intercept, which is my b value in my equation. So it's at a positive 6, so I put plus 6. And when I simplify, I get y equals x plus 6. So that's a 6, sorry guys. So it matches what we said our equation should follow. All right, looking at the back side. All right, we have some information here. Plane A is at an altitude of 30,000 feet, and it is descending at a rate of 1,000 feet per minute. So this is our starting point, our starting value. This is going to be our rate of change. All right, so when we take a look at this one, I already know that I'm starting at 30,000 feet. Descending means I'm taking off 1,000 every 1 minute. So there's our format. So looking at our format, it looks like it's in the format of y equals b and then minus mx. But remember, that's the same thing as if I were to do b plus mx, where it's adding a negative m value. All right? So this looks like this should be a non-proportional relationship. So let's look at the data. Fill in your data. So our data for 0 minutes is 30,000. In 2 minutes, it's 28,000. In 4 minutes, it's 26,000. 6 minutes, it's going to be 24,000. And in 8 minutes, it's going to be 22,000. So if I want to know if it's proportional or not, I'm going to set up my y over x. So this is my ratio. Remember, it is not your slope. So I'm going to have 30,000 over 0, 28,000 over 2, 26,000 over 4, 24,000 over 6, and 22,000 over 8. So we're going to reduce these. When I look at this one, I'm going to skip it because I cannot divide by 0. It's undefined, remember. So 28,000 over 2 reduces to 16,000 over 1, which is 16,000. 26,000 over 4 reduces to 13,000 over 2. And when we look at this, right away I should see that if I reduce this even further, this is not going to equal. So therefore it is not proportional, which matches what we said it should be in the format of y equals mx plus b, or in this case, b minus mx. All right? So if it matches, let's take a look if I were to graph it. So graphing this plane, at 0, we're at 30,000. At 2, we're at 28,000. 4, we're at 26,000. 6, 24,000. 8, 22,000. And we can continue our graph. So when you look at your graph, your data